Have you ever wondered if drones or uncrewed aircraft systems can be used to monitor agricultural farms? Well, I carried the same curiosity almost 3.5 years back, and now my research focuses on the application of drones in agriculture. My name is Nitin, and I'm a PhD candidate at the Department of Ag and Biosystems Engineering. According to a survey, the world population is about to reach 9 billion mark by the end of 2030. With that population growth rate, farmers are expected to use advanced technologies that are fast, reliable, and sustainable. One such technology is drones in agriculture that can be used to monitor weed growth. Now, as we all know that weeds are unwanted plants that compete with crop plants for sunlight, water, nutrients, and whatnot. For example, a weed by the name of kochia reduced corn production by over 90%. But there is a hope. Do we know that these weeds could be eliminated by such advanced technologies in real time? Well, allow me to do some time traveling here. In the late 1970s, farmers had to literally walk miles in order to eliminate weeds. Another 20 years, and we have sustainable conventional sprayers. Fast forwarded to another 20 years, and we have drone technology. So as a 21st century ag engineer, what role do I play in making contributions and advancements to such technology? And the answer is, I teach drones to identify weeds amongst crop plants. So questioning the gist of my research, how do I teach drones? Well, imagine teaching a 4-year-old kid about how an apple looks like. You may start describing its features, such as an apple is red in color or has a crisp texture or is roundish in shape. A computer is just like that 4-year-old kid. In our research work, we collect thousands of images of weeds and feed it in an algorithm called as machine learning algorithm. What these machine learning algorithm is capable of achieving is extracting those relevant features from a specific class of weed species. Once we have the features modeled, we take this model to an unknown location to identify weeds. As of now, our model has been able to achieve 85% accuracy in identifying 5 different species of weeds across 2 locations in the state of North Dakota. Moreover, our model is compatible and can be integrated with the technologies that are used by growers and farmers to identify weeds in their locations as well. So does the future of agriculture take flight? Yes, of course it does. So the next time when you're about to have a delicious meal, think about these advanced technologies and farmers' effort in quenching your starving tummy. Thank you.